This lesson is on common factoring and will compare the act of common factoring to using the distributive property. You can see on the left here that there is an image that I've used algebra tiles to show an expression. So these algebra tiles represent x, and these represent ones. So we can say that there is a length and width to this. So for instance here, we could say that has a length of 4 and it has a width of x plus 1. So that means that I can represent this whole thing as 4 times x plus 1, because as we know, area of a rectangle is length times width. So you know that using distributive property, we can then show 4 times x is 4x, and 4 times 1 is 4. So this expression is the same as 4x plus 4. And let's take a look at this for a second. You can see that in total we have 4 x's plus 4. So the total area can be represented by 4x plus 4. So we can also do the reverse. If we start with 4x plus 4, we can work backwards to our original statement by noticing that both things are divisible by 4. In other words, 4 is the greatest common factor, or GCF. This is the first lesson of a few that you will see on factoring, as factoring is a commonly used mathematical tool, and common factoring is always the first step used even when we get into more complex factoring. When common factoring, we're looking for the greatest common factor, or GCF, of all of the terms. So we'll do a couple of quick examples here by finding the GCF for these statements, the terms that are shown below. So here we have 6 and 15. 6 can be written as 2 times 3. 15 can be written as 3 times 5. So I see that we have in common is the 3. So therefore, the greatest common factor is 3. Now let's take a look at the next one. This can be written as 2 times x, and the second term can be written as 2 times 2 times 2. That's written as its prime factored form times x. So we can find that there's a 2 that we can use in both sides and an x. So our greatest common factor in this case is 2x. One more quick example. This can be written as 3 times 7 times x times y. The second one can be written as 5 times 7 times x. And finally 2 times 7 times x times y times y. I can see that there is a 7 in all three terms. We can only use a GCF if it's in all of the terms. There's also an x in all of the terms, but there is not a y in all of the terms, as the second term does not have one. So therefore, our greatest common factor would be 7x. Okay, let's go through an example, starting with an expanded form and factor it. So we're going to factor this expression. 2x squared plus 4x. I've represented it with algebra tiles. This represents x squared, x, 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 and x. And you can see that in total we have 4 x's and 2x squareds. So everything that's in the expression is represented in the image. What we want to be able to do is to write this in factored form. So it needs to be written as multiplication. So we can use what's in the diagram here to figure out a length and width. Since it forms a rectangle, it definitely has a common factor here. So this side is 2x. Right? We get x plus x, so that's 2x. On the other side, we get x plus 1 plus 1. So this will be x plus 2. Therefore, we know that we can write the final expression as 2x times x plus 2. Let's try looking at this without the image. So I can consider 2x squared plus 4x. What is the greatest common factor? Well, it looks like the greatest common factor is 2x. 2 divides both terms, and nothing greater will do so, and x divides both terms. X squared would not. So that means we can divide 2x from both terms. 2x squared divided by 2x is x. I'll throw that down here. So 2x squared divided by x equals x. Because the 2's divide out, and one of the x's divides out, so we're just left with x. Plus, well, 4x divided by 2x. The x's divide out, give us 1, and 4 divided by 2 is 2. So we can confirm, both with the diagram and algebraically, that the answer is 2x plus x plus 2. Or sorry, 2x times x plus 2. We'll work through one more example without the use of algebra tiles. So we need to find the GCF. So let's write these out in their prime factored forms. 24 is the same as 2 times 2 times 2 times 3. And then we have 3 x's. 60 is the same as 2 times 2 times 3 times 5. And then we have 2 x's and a y. And here we have 2 times 3 times 5 times x and 2 y's. So what do we have in common? We can see that there's 2 in each one. There is a 3 in each one as well. And we can find an x in each one. So our greatest common factor of the 3 terms is, 2 times 3 times x, or 6x. So that's our rough work there. So 24x cubed plus 60x squared. y minus 30xy squared equals 6x. And what do we have left? You can take a quick look. What'll be left? 2 2's, 2 x's, 2 times 2 is 4, which makes sense. 24 divided by 6 is 4. So we get 4x squared plus, you can verify again by looking above or doing the math, right? 60 divided by 6 is 10. X squared divided by x is x, and we still have the y. And you can verify that knowing that there's 2, 5, and an x and a y. And finally, negative 30 divided by 6, that's negative 5. X divided by x leaves us with a 1, so there are no x's left, and y squared. And again, you can verify that with your work at the top. We have 5 left and 2 y's. All the extra work done at the top is not something you have to show. I'm just trying to show my thinking to help those of you that need to see that extra piece. So we can see our final answer. There are no more common factors to all 3 terms, so we know that this is complete.